Multiplying fractions may be the easiest thing we do with fractions of everything. So let's look. 2/3 times 4/5. All you do to multiply these is multiply across the numerator. 4 times 2 is 8. And multiply across the denominator. 3 times 5 is 15. Done. Multiply across the numerator. Multiply across the denominator. Done. Reduce if you can. So let's do some examples. Let's multiply -3/5 times 11/12. Now, a secret, I know I showed you here, just multiply across and get a value, but there is a step you want to take in between that will make your life much easier. First, it's a negative times a positive, so the answer is going to be negative. Then don't multiply across and get 33/60. You can do that, but it's easier if you multiply across, keeping them as separate values that have to be multiplied. 3 times 11 over 5 times 12. And the reason that's easier is once you get here, now you can use a cancellation. You can notice that 3 divides the factor 3, leaving a 1, but 3 also divides the factor 12, leaving a 4. So you can do these reductions here much easier than you can do the reductions later after you've multiplied everything together. And I'm going to do it both ways to show you. So I have a negative 1 times 11 is 11 over 5 times 4 is 20. So negative 11/20. So the other way you could do it, let's take it over here and do it. -3/5 times 11/12. So -3 times 11 is -33, and 5 times 12 is 60. Well, first off, you have to work pretty hard to get 5 times 12. You definitely have to work harder to get 5 times 12 than you did to have to get 5 times 4. Not that you don't know 5 times 12 is 60, but it's just more work. Then you have to work harder to figure out what these both divide by. Well, they definitely both divide by 3. So if I divide the numerator by 3, it leaves, well, actually, let me take that back. So when we do these cancellations that I showed you here, what I'm actually doing is I'm writing -1 for the negative factor times 3 times 11 over 2. 60 divides by 2, leaving 30, which divides by 2, leaving 15, which divides by 3, leaving 5, which is a prime. So I can pop these totally allowed, and then I can cancel the 3's because they're common. That's what I did over here in the blue here. I noticed that 33 divides by 3, and what's left is -1 times 11, -1 times 11, and 60 divides by 3, leaving 2 times 2 times 5, which is the same thing as 20. Here it is, 20. Okay, so I canceled out the 3, and it's 5 times 4. That's what I was looking for, 5 times 4. So all the same stuff, totally legal to do it this way, just a lot more work to do it this way. And believe it or not, algebra really is about making less work in really hard problems. It's just that we have to make easy problems seem harder in order to develop that. So these are both forms of reducing. This is reducing by pop, right? By product of primes. So we write them as a product of primes and cancel whatever's common. And this is reduced by cancellation. L-A-T-I-O-N? Yikes. Good thing I'm not an English teacher. So this is reduced by cancellation, and this is reduced by pop. Two different ways to work. You're going to want to use cancellation eventually. Right now, it's okay if you use pop. Let's do another example. I'll be using cancellation, by the way. Let's multiply 23 thirds times 27 tenths. Okay, first thing I want to do is multiply across. So 23 times 27 and then 3 times 10. And I'm going to use the cancellation method, so I don't want to multiply my numbers together. So 23 times 27 This time I'm going to use a dot instead of parentheses. No reason, just to show you that it works both ways. And 3 times 10. Now that they're in the same fraction, I can use cancellation. I can look for things that divide a number in the numerator that also divide a number in the denominator. So 3 and 27 have a common divisor. It's 3. So I can cancel 3. 3 divides by 3, leaving a 1, and 27 divides by 3, leaving 9. Now I look for some more cancellations, and I don't have any. So now do my multiplication. 23 times 9. Are you kidding me? 23 times 9. 9 times 3 is 27. Carry the 2. 9 times 2 is 18, 19, 20. So 207 divided by 1 times 10. Okay, let's do a few with monomials in them. Let's multiply c over 7, or c divided by 7, times 14/15. All right, c times 14 over 7 times 15. Look for common factors. 7 and 14 both divide by 7. So 7 divides by 7, leaving a 1. 14 divides by 7, leaving a 2. And I don't see any more common factors, so I'm going to go ahead and put it together. C times 2 is 2c over 1 times 15 is 15. Let's do another one. These are kind of fun, aren't they? Negative 2x cubed over 9 times negative 3x over 4. All right. Well, we're multiplying a negative times a negative, so the answer is going to be positive. So I can just ignore the minus signs. And then 2x cubed times 3x over 9 times 4. Now these are a little bit more complicated, and in this case it's better probably to rearrange it so that all of our integers are together and all of our variables are together. So in the numerator I'm going to write 2 times 3 times x cubed times x over 9 times 4. Okay, so I just put it all together with in a different arrangement. I'm allowed to do that with multiplication. Multiplication is commutative. And now I want to do my cancellations. Well, I have a 3 in the numerator and a 9 in the denominator that cancel. 3 divides by 3, leaving behind a 1. 9 divides by 3, leaving behind a 3. 2 divides by 2, leaving behind a 1. And 4 divides by 2, leaving behind a 2. So now I have my new values to multiply, and then this is just variable multiplication, which we remember how to do. 1 times 1 is 1. I have 3 x's and 1 more x. Remember, you add the exponents, excuse me. You add the exponents, so I get 1 times x to the 4th over 3 times 2, which is 6. And so I would probably clean this up and just write x to the 4th over 6. So these last ones can be just a little bit complicated, needing a bunch of time, and you'll need a bunch of time in class to practice, and luckily I'm going to give it to you.